By the end of this Blender tutorial, you'll be able to make this brilliant fiber optics design in geometrynodes. Let's get started. Let's Control I to invert selection, X to delete. Reselect the cube and go up to geometrynodes tab. We'll add a new geometry node setup. And we actually don't need the incoming geometry. We're going to create our own. So the first thing I want to do is create the curve that we'll be shaping. We can do that with a curve line node. And we'll just right away connect this to the output and we can start looking at it in the 3D viewport. So this is just 1 meter tall, but we want that to be an input value. So let's add a combine XYZ. And for the Z value, we'll add a group input and we'll press N, bring up the sidebar here and rename that strand length. So right now it's it defaulted to 0. So we'll actually make that default 1 and bring 1 back. So now we can adjust the length of the fiber optic strands. Now you'll notice in the spreadsheet that we have 1 spline and it has only 2 control points at the bottom and at the very top. So to bend this or to reshape it, that won't work. We need a bit more resolution. So we'll shift A to add a resample curve. Now you can see there's a lot more control points here and that'll give us a lot more resolution. And it would be useful to add a group input for the resolution, which we'll come over here and call strand resolution. So now we can adjust, you can see in the spreadsheet how many control points are actually in this curve. So we'll set this to 10 and we'll maybe add it as a single value. All right, so that is our basic strand setup. We can grab all these nodes, press Ctrl J and F2 and call this strand curve. So now that we have our strand, we can start distributing those. To do that, we'll want let's do a mesh circle. And this has a radius that we can specify and also resolution. For now, we'll just fix that at 12. But the radius, again, we'll want to be able to control that within the modifier. So we'll rename this to be base radius. This will be the base circle, and on this circle we'll distribute all the random points that will instance the fiber optic strands. And you can press Alt, Shift, and left click on this node to automatically connect it to the group output. So there's our circle. We'll actually want the fill type to be Ngon, I think we'll do. And on this circle, we'll want to distribute points on faces. But we have all of these points now. And instead of random, I want to be able to control a little bit where these points are placed. So by changing it to poison disc, whatever you want to say, it gives us the ability to tweak a few more values. So the distance between these points, we'll actually want it to be whatever we decide the radius of the strand will be. So those splines will eventually be cylinders, essentially. And we want these points to not get so close that the cylinders intersect. We want them to be separate enough so that they're side by side. That's the distance of 2 radii. So to specify that, we'll say minimum distance should be whatever the input of this radius is. We'll call it the strand radius and bring in a math node and say times 2. And that will prevent them from being so close that they will actually intersect. So as we increase the strand radius, you can see that these points start to disappear because they would be placed too close to each other. Okay, so let's name this, we'll Control J, F2, and call it base. And here we'll group these together, Control J, F2, and call it distribute. So now that we have our points, we can add a instance on points node. This will go in the distribute group, and let's bring in this curve to be the instance that we want to see on those points. So they look pretty spread out. We can of course change the radius of the base, and the strand radius we might set to a small amount, and maybe let's increase the strand length quite a bit. All right, so now we have these fiber optic cables, but they are, as mentioned, these are perfectly flat, which really doesn't look that interesting. So we'll mix it up a bit. What we'll do is we'll randomize the length a little bit. And in the instance on points, we have this scale input. And if we adjust this Z scale, you can see how the height changes. What we can do is add some randomization to it. And to do that, we'll Shift A to add a random value. We'll change it from a float to a vector. And we only want to affect the Z-axis. So we'll change the X and the Y values to 0, and then we'll specify some amount. We can start with maybe negative 0.5 to positive 0.5. And that's the amount that we want to add to the current scale, which is 111. So we'll add a vector math node. The current scale is 111, So we'll just click, drag down to select all 3 fields and press 1 and enter. Now we want to add this random value and connect that to the scale input. And you can see that the heights adjust. But the randomness is a little bit too much. So let's add another control where we actually scale the output of this random value. So let's grab the vector math node, Shift D. We'll change that to scale, and let's add a group input slider here. And we'll call that length randomness. And default to 0. And subtype, let's change to factor. That will give us min max 1. All right. So by specifying the min and the max 1, we get this slider bar here. So it's full random, no random. And you can see in the 3D viewport that without any randomization, we have that flat top. But if we start to add in some randomization, we get that variation that we're looking for. And another thing you can do is add a group input to this randomization seed. Call that height randomization. Make it a single value, and we'll just change that until we like how it looks. Super cool. Let's take these nodes here, shift drag a box around all of them until they're selected. Control J, F2, and call it height randomness. Awesome. All right, this is looking great. Let's move on to the next part where we'll actually start to shape the fiber optics, where they'll bend more on the top and on the bottom they won't bend as much. Before we jump to that, I'm just going to clean up some of these inputs. All right, so how do we rotate these splines? Well, a quick way to get some effect to see would be to bring in a vector rotate node. And the output of this will be a vector which we'll use to set the position on these splines. But before we can actually use this setup, if you look in the spreadsheet, we have only instances to work with. Those instances have positions, which was the points that we saw distributed on the base, but we don't have actual control points in these splines. In fact, I called them splines earlier. I misspoke. They're instances right now. So before we set the position, we need to realize the instances. So what that'll do is basically promote the instances to actual curves, actual splines that we can work with. And this is overlapping, but you can see that we have actual splines, and then we have a lot more control points to work with. And so the position of those control points is what we want to set so that we can give it a bending shape. So now if we take Shift A, bring in a position input, that's the vector, that's the position that we want to start with. And we want to rotate that around a center on, we'll say, the y-axis, so that it will bend around this y-axis. So if we say z0, y1, and plug that into the position and give it some angle, you can see how it starts to rotate. Now I have some work to do though, because it's rotating everything around that one center point. So the first thing that we can do is make sure that each individual strand is bending around its own bottom position, not everything in the center. But in order to do that, we need to actually not use this position node, so we'll press X to delete that. We want to use the position of the instance. And at this point, we're actually past the realized instances, so we're no longer working with instances. So we need a way to be able to get information about the instance and its point and bring that into the vector rotate node so that we can set the position on the control points. It's a little confusing, but this will make sense in just a minute. So that's what the capture attribute node does, or the store named attribute. These two nodes basically record data at some point in the node graph so that you can retrieve it later on. And let's actually use the store named attribute. So let's store a vector because we want to store the position, and we want to store it in the instance domain. Let's call it instance position, and the value will be the input from the position field. So for every instance that exists, we'll record the instance's position, which is just the points that we distributed on the base. So then after we've realized instances, convert it into actual splines to work with, now we can take a named attribute node, change it to vector, and we'll use that instance's position to be the center point around which everything rotates. So now if we bring in another position node, this will be the position of every control point in these splines. Those are the positions that we want to rotate. And now if we give that an angle, you can see how at the very bottom, everything stays in place. It's bending around its own center point. But we want to be able to rotate not much at the bottom, a little bit more in the middle, and rotate the most at the top. So we need to be able to set some kind of scalar value as far as how much it's actually rotating, depending on where those points exist within the length of the spline. So the first thing we can do though is bring in a group input. We'll call this bend, and it is an angle subtype. Default will say 0. Min can be -pi. I'm just throwing in values here, and max can be tau, which is 2pi. Make it a single value. And now we do have control in the modifier stack. But this amount needs to be tweaked. If we bring in a spline parameter node, this gives us the factor. And this factor field will output the value between 0 and 1 of where the point is within the spline. So at the very bottom, its spline factor is 0, and at the very top, its spline factor is 1. And it will give us values for all the other points in between. So we know that at the bottom, we're essentially bending it angle times 0, and at the top will be angle times 1. So let's just do that. Let's add a math node. We'll take the degrees we want, times it by the factor, and now we have this shape, where at the bottom it's not bent as much, but at the top it starts to bend more. And if we want to be able to shape that a little further, we can bring in a float curve. And with that float curve, we can tweak that factor a bit and adjust how much it's actually bending. So maybe about like that. Let's give this a bit more length. And now you can see this starting to look like that mushroom shape if you imagine it this way, which will start. And that will be the next step. How do we bend it so that it bends basically in a circle and not just around one axis? Well, going back to the vector rotate node, we have this axis input. Well, what does the axis look like? If we option shift click the distribute points on faces and go to the top view, you can see that all of these points have some distance from the center. So for example, this point here, we want it to curve this way, away from itself. And the axis is basically perpendicular to this vector, this angle. So if we get this vector, rotate it 90 degrees, we get this perpendicular vector. And if we rotate it, this strand will actually bend this way. And the same here, 90 degrees here. This strand will bend this way. And that's how you start to get all of these different strands bending in a circle around their own center points. So if we take this named attribute output, which is already the instance position, let's normalize the vector so it's a length of 1. And then we can vector rotate that vector by 90 degrees, and we'll rotate that on the z-axis. And that will be the axis that these strands rotate on. So if we go back to set position, and we connect this to the geometry output, you can see that they're starting to branch out all around. I don't like this length randomness. Let's turn that down a bit. That's looking better. But let's bend it a little bit more, give it some more height. Now the next step will be to give this a bit of a dome so that we have longer strands in the middle. So strands in the middle won't bend as much. We'll still have tall strands here, and strands further to the outside of that base circle will bend more. So let's hone in on this setup here, which maybe we'll call this, we'll Control J F2 and call it bend less at the bottom. And we want to add to this. So let's go look at those points again. Option Shift click, top view. We need some kind of mask so that points that are further away from the center bend a lot more than the points that are closer to the center. Again, we know that we can get the distance, the length of this vector, by just the instance position, because it's based at 0, 0, 0. It's based at the center point 0, 0, 0. So the actual position values of this will be the vector, and we'll take its length. So here we'll bend not as much in the center, and here we'll bend as much as we would expect. So basically we just want to create some kind of factor a value of 0 to 1 that we can times this value by. And Alt-P will actually remove a node from some group. So to create that factor, let's bring in this named attribute, which is the instance position again. And if we take its length from the vector math node, that will give us values of, say, 0 if it was right at the center, or values of r, depending on the base radius specified here. So if we crank this up to 2, the range of values would be 0 through 2. Again, we want to produce values from 0 to 1, so we'll need to take the length and use a math node to divide that length by the group input base radius, and that will give us values of 0 to 1. So if we plug that into the second part here, Option Shift, click the set the position, now we see that we have this kind of dome shape. So let's change the base radius to something so it's a little slimmer. Maybe we'll just go with 1, but let's crank the density really high, up to maybe 100. And another thing I want to do is make the stem a little bit skinnier, so let's reshape that a bit with this factor here, and maybe tweak the base radius. And since we may want a bit more density, let's make this a group input, default 100, and we'll call it strand density. That'll let us add more and more strands if we want, depending on what look we're going for. In fact, what does it look like if we really crank that up to 400? I think that's looking pretty good. If we go to the top, you can see that all these lines are perfectly pointing back to the center, and it doesn't look very natural. So another thing we can do is with that axis over here, and maybe we'll disconnect this so it's a little cleaner. Let's add a bit of randomization to the rotation. So we'll again Shift A to bring in a random value, change that to a vector, give it maybe -1. I guess it's on the Z value. -1 to 1, and then we will bring in a vector math node, add that, and it goes crazy. So now a little too unnatural, so let's dial that back. Let's get a bit more space to work with here. Let's dial that back by Shift D this length, and we'll change that to a multiply. And this, we just want the Z value to be affected. So this will be a combine XYZ. But the problem here is that every point is getting its own random value. So we need to be able to basically group these points so that all the points from one instance have the same rotation, have the same random value added to its rotation. So that will require another capture attribute. Before we realize the instance here, we'll store another named attribute called instance ID. And that will be an integer, and we'll grab the ID input and plug that in there. So now if we come back down, take this named attribute here and bring back the instance ID, that attribute will plug into the ID. So as soon as you do that, you can see it goes from super frayed to more organized, but still random. You can see how they kind of curve in different directions. So again, instead of every single point getting a random value, now it's just one random value per strand. All right, so I think that's looking pretty good. You can tweak it as much as you want with all the different inputs we have. This length randomness, maybe I will make a single value. Before we jump over to the shading though, I know that we will need some information in the shader, and I actually want to take out this multiply node. I'll Alt drag that out. And I want to use that actually as a scale, which I can control with a group input to be able to knock back that rotation randomness. Again, we'll make that default 0, min 0, max 1, single value, and that will let us change around how much these strands are rotated on a slightly different axis than that perfectly perpendicular axis. So it looks a bit more natural that way. All right, I think we're getting close to being able to add some materials to this, but a few more things that we need to do is let's actually convert this finally from a curve to a mesh. We'll need a profile curve, which will have a circle curve. Resolution for now, we'll just say 3. And if we plug that in and add a group input, strand radius, and add just a group input, let's pick that existing strand radius to plug in there. That's super fine. And then to hide all these inputs that we don't need, we can Control H, and then we just see the one that we're interested in. So now the strand radius, we can adjust to be 0.05 maybe, whatever looks good. And the strand resolution, if you bump it up to 20, you'll get a smoother curve. So that's looking pretty good. I know that as we go into shading, we're going to want to colorize this with different colors depending on how far from the center they are. And we already did that calculation down here. So let's take this output of this calculation, which is basically its center offset, and let's store that in this geometry. Let's store a named attribute. Take that value. We'll call it the center offset. And again, that's a value from 0 to 1. So it'll be a float, and we'll store it on, I think if we store it on the point domain, we should see it in the spreadsheet. We can verify that it still exists as we're viewing this group output. We have the column here, so we have stored that properly. Awesome. So now let's jump over to shading. Let's go into the shading editor. Let's collapse this. Just get set up here really quick and turn off the world opacity. All right, I'm excited for this part because this is the part where it really starts to come to life. And I've set up this image here so that we can reference it. With fiber optics, they're brighter, at least like these decorative cables, they're brighter more at the top of the strand than they are in the middle of the strand. So we'll want to keep that in mind as we build out our shader. First thing though is select this node, press X to delete it, and Shift A to bring in an emission shader. We'll plug that into the surface. Go up to our viewport, press Z, make sure that we're in material preview, and let's give this a name. Call it radial rainbow. And we need to go back to the geometry nodes and add a set material and select the radial rainbow. So now, if we bump this value, we can see that we are actually affecting the material. Great, so let's give it some color right off the bat. Let's pull in a color ramp, and I want to take the HSV and set it to far, and let's pull in a red and then a blue at the very end of the spectrum. This could be whatever colors you want, of course. It could be a purple. Yeah, let's go to purple. And let's plug that into the emission. Let's give the strength, for now we'll give it like a 10, just so that we can view it. Now I want there to be, if we go to the top, I want there to be a fall off. From the middle outward, I want this color to fade to this color. So to do that, we should have access to our attribute, which we called, I think it was center offset. So if we take that factor to drive it, there's our fall off. And let's go to the render tab, go to color management, just kind of play around with this. Filmic is a lot more vibrant. Maybe filmic for now, and maybe a medium high contrast. And let's go to render engine Eevee give it some bloom. That's probably good as default for now. So now we're starting to get the color, the brightness, but we definitely don't want color all mostly up through the strand. So let's dial that light back. Let's duplicate this attribute node and let's rename it to, we'll have to check the geometry nodes. Which attributes did we store? Oh, we didn't actually store the spline factor. We used the spline factor down here, but we didn't store it up in this geometry. So let's kind of backtrack. Let's take another store attribute node and we'll name this spline factor. It might have to come on this side actually. It'll be a float and the value will be the spline parameter, and that factor will plug into the value. And we'll store this on the point domain, hopefully. And if we inspect over here in the spreadsheet, we do have the spline factor. That's one of the benefits of using the store named attribute instead of a capture attribute, because the capture attribute node is considered an anonymous attribute. And so you don't actually see the values in the spreadsheet. So for debugging and just confidence check, using the store named attribute, giving it a name, and then verifying that that data does exist where you expect it is really useful. So back in shading, if we were to access those values using the spline factor, and using that to affect our emission, we can plug the factor right into the strength. And now we can start to shape this factor, which is just 0 to 1, but we want it to be bright at the bottom maybe and brighter at the tops of the strands, but not so much in between. So if we set this to 1, add another stop here, and then after that stop, we'll make this darker, change this to maybe B-spline, cardinal, darken this. Just trying to find the right shape here. This should be darker as well. Maybe a little bit brighter as light starts to bleed in. If you need a bit more resolution here, you can drag this out. I will actually darken this a little bit more. That's looking pretty good. I think for this value, we can blow this out. Right now we have a value of 1, but we can make it super bright. We can pump that. We can only go between 0 and 1 with the slider, but if we pump that up to 5 manually, what happens if we just crank it? Yeah, it gets super bright. So I guess this value here too, we could go a little bit brighter. Let's go to rendered and see what it looks like. Let's go to the world shader and mute that and go back to our object. Let's also add in some glossy, and we'll add in an add shader to mix these together, or to add them together. And we'll dial down the roughness, and we'll maybe add a translucent shader as well. Sweet, so it's looking pretty good. You can always tweak the modifier here. I want to tweak this black, so we can do it with a brightness contrast node. And we can just bump the brightness a little bit so we can see those strands a little bit better, as if there is light still going through. And finally, let's animate this so that over time we'll get these colors rippling across the fiber optics. So let's pull in a value node, and if we type #frame, if we press spacebar to play the animation, maybe I'll just pull up a timeline here. So as these frames increase, we get the same increase in this value. So now we can use that value to drive, say, a hue saturation value change in this color, and we can shift the hue around. Right now it's going to be super fast, if it works at all, because we want this value, the hue value should be between 0 and 1, so let's add some math here to divide this by some number, let's say 180 for now. And you can shift left arrow and shift right arrow to move between, if you look at the bottom, to move between the start and the end frames. So shift left arrow, press spacebar to play, and you can see how the colors change. That might be a bit too slow, so we can speed that up. So one thing I did was I came over into the render settings, and at the very bottom I changed the exposure to be 2.5, and that gives it a bit more, so you get that whiteness going on. I dial back the brightness here, so I'm not actually using this node much, so this brightness contrast node, and I like the look of that a little bit more. And that bloom now, if I go back into the render settings, the bloom intensity is a little bit too much, so let's knock that back just a little bit, maybe 0.03. So there's a couple things I want to do before we finish up, just to touch this up a bit more. Let's actually go to the Layout tab, and let's give this a base. If we Shift A to add a cylinder, change it to 12 vertices, and we'll Alt Z so that we can see through our mesh, and grab that bottom face, press S to scale that, grab the top vertices, press G and Z, maybe grab all the vertices and scale that up a bit more. And then I want to grab this bottom face by pressing 3 to go into face select mode, click, Shift S and cursor to selected. And what that will do is, if we tab into object mode, right click, set the origin to the 3D cursor, and Shift S, cursor to world origin, and this is jumping around because I have the lock to 3D cursor on. And then if we Shift S, selection to the cursor, that will jump the base up to the ground plane. Now, we didn't parent this, so we'll have to move it up just a little bit more as well. But I think that looks pretty good. It might be a bit too tall, so we'll select the base, press Tab, and 2, and Alt click one of those edges, and G and Z just to move that down a little bit. Tab back to object mode. So let's actually add a bevel modifier to this. If we go into our modifiers tab here, click to add bevel, give it 3 segments and a bit more on the amount until it looks good. And then press Ctrl 2. You can Alt Z so that you're not in X-ray mode anymore. And right click to shade smooth. And finally, let's actually give it some inset. Click and tab into edit mode. With that top face selected, press I to inset. And about there. And then E to extrude that down. And then tab back to object mode. Lastly, let's give that some shading. If we select the base and go into our shading, click new. And let's go into material preview. Let's give this some transmission and turn our roughness down. This will be just a really basic shader. Now for Eevee, there's several settings that we need to turn on so that we can actually see that transmission. If we go into the render tab here at the top, go to screen space reflections, turn that on, and expand that menu and turn on refraction. Now if we go to the material tab, and let's bump this refraction depth, and at this point let's go to rendered to see what that looks like. What I'm expecting to see is the light shine through, and it's definitely not yet. So I think the last thing is to turn on this ray trace refraction. And now we start to see some of that light come through. We can move this up a little bit more if we want. So that's looking pretty good, but I'm still not sold on how dark these strands are. So let's click our strands and let's tweak this a bit so that we have actual light coming through these strands. So the main thing that's driving that is this color ramp down here. So let's play around with these values. That's okay, but I don't actually want bright light in the middle. So maybe let's add in a mix RGB, a mixed color node, so that we go from whatever this color is with some extra white coming up the middle. So add another color ramp, and let's flip this color ramp, and let's make this the driver of this factor, this mix factor. So we see a little bit of color, but let's actually drive this color ramp with the factor of the spline factor. And I want the color to come through at the bottom. I don't want there to be color in the middle, but then at the top, I do want there to be more color. So let's just shape this. And let's dial this back a little bit. It's good, not great. Let's maybe remove these blacks here so that we're not timesing that by 0. That's looking a lot better. That's kind of what I was expecting. And maybe give it a bit more white. Let's see. I like where the light is there. This might be too dark. It's looking better. It's a very faded color, so it's not like it's full brightness, which, yeah, I think I like that. This might be too high, so let's dial that back a bit more. Just finessing this to get kind of the shape and the color that I expect for this fall off. The fall off of the light, I think that looks pretty good. I like that we can see the white now. It looks bright, especially in this super black environment. And to tweak this base, I might go back here and make it a little more rough, just so that it's more blurred and you don't see those edges there. So increase the roughness a bit more and give it just a bit more bloom. Alright, so here's the result of the project. Let us know in the comments how yours turned out, and if you enjoyed the video, like the video, and subscribe to see more Blender tutorials in the future. See you next time.